Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we're looking at worksheet 4.6b for Math 1. Remember, every problem in the homework mirrors the exact problems on your homework. So if you're having a problem with one problem, fast forward to that one and we should be able to give you the help you need. So let's get started. Problem 1, think about a plan. You are fencing in a rectangular area for the garden. You have only So I have a rectangular area. I have only 100 feet of fence, and I want the length to be 30 feet, and I want the garden to be at least wide, at least 5 feet. What is the graph showing the possible dimensions of your garden? Well, first of all, remember we're dealing with a rectangle. So that means I have a rectangular garden, which means I'm going to have a length and a width. All right? And it's going to be 100 feet. I have a length and a width. Well, that's going to be my two variables. So my two variables are going to be, I'm going to let x equal the length and y equal the width. In other words, I'm going to let this, if I were to erase this here, for example, I'm going to let my width, my length be x, and my length be y. All right? If I want to erase those and make it clear with you here. So I'm letting my length here be x and that be y. All right. How many inequalities do we need? Well, look at the numbers we have. First of all, we only have 100 feet. So that's length and width all the way around. So that's the first equation. Then I want to have an equation for the length less than 30 and the width less than 5. So I'm going to end up with 3 equations. So my first equation, let's start with the 100 feet of fence. All right. 100 feet of fence. That's over here. How wide is my garden? Well, it's x plus y plus x plus y, or as we often say, 2x plus 2y has to be less than 100. Okay? So to graph this, let's start by looking at our boundary line. The boundary line is going to be 2x plus y equals 100. Easiest way to graph this is to find the two intercepts, the x and the intercept. If I start with the y-intercept, let x be 0, and I just have 2y equals 100. So divide by 2 and y equals 50. I can come over to my graph and I can mark in the 50. That's my y-intercept. Similarly, for the x-intercept, let y be 0, and so 2x equals 100, and that intercept is also 50 down there. And so to draw my graph, all I have to do is connect the line. And so there's my line. This is less than solid, so it's going to be below. So in essence, I'm going to end up with my graph, generally speaking, somewhat like that. So all my things, because I only have 100 feet of fence, they have to fit into that area. Second equation then, let's look at our length. Our length has to be greater than 30, so the boundary line for that is x equals 30. So that's easy to draw here. It's going to be greater than or equal, solid above. So there's my 30 line. Above this time is a little difficult because it's a vertical line. Above means greater than, so it's going to be to the side, all right, to the right side. So we're going to end up here with, this is going to graph this way. Okay, and you notice here, down here is where my red and these are combining. If that was all there was, we would say that's the area there. But finally, we have to deal with the width. The width they want to be greater than 5. So again, the boundary is y equal to 5. And I'm going to have a solid line above. So I put in the line 5, and I'm going to grade above. So we're going above the green line. And if you look there, you can see it's in here that we have where everything comes together. And that ultimately is our answer. The yellow that I've graphed there is where is both less than the red, greater than the green, and greater than the blue. So that's our graph. Problem 2 asks us to graph the system y is greater than 2x plus 3 and y is less than or equal to 2x minus 5, and then answer a couple of questions. So let's start by graphing the system. First off, I'm going to graph the system, the first graph, y is greater than 2x plus 3. So the boundary line for that would be y equals 2x plus 3. Notice that the slope is 2, and the y-intercept is 3, so we can use that to graph. First, we'll use the y-intercept and go up here, 1, 2, 3, and then my slope is 2, so that's going to be up 2 and over 1. So that's going to be the next point. But before I draw my line, I need to remember what kind of inequality is this? And notice I have a greater than, so that means my line's going to be dotted or dashed, and I graph above. So there's my dashed line, and I'm going to graph above. So there's the first one. All the lines above that dotted line, but not including the line. So let's go to our second graph. Y is less than or equal to 2x minus 5. Once again, the boundary, just put the equal sign in for the inequality. The boundary is y equals 2x minus 5. Notice the slope is again 2, but this time the y-intercept is negative 5. So I can go to my thing and come down from the 0 point, 1, 2, 3, 4, 5, and that's where my point's going to be. And now my graph would be again up 2 over 1, so like that. But I need to check and see what kind of line we have. Less than or equal means the equal part means it's going to be a solid line, like that. And the less than means I graph below. So that's what my graph looks, all right? So the question is, will the boundary lines y equal 2x plus 3 and y equals 2x minus 5 ever intersect? And the answer is no, because you notice that they're parallel lines. So as a result of being parallel lines, they're never going to actually intersect. Second question, do the shaded regions from part A overlap? And you can see no, the blue's going this way, the red's going this way, and so they never are going to touch. So the answer to that, of course, is no, they don't overlap. So does it have any solutions? And the answer again is no. There's no points that are both below this line and above this, no points that are below this line and above this line. So there are no solutions for this equation. Problem 3 is an error analysis. A student graphs the system as shown at right. Describe and correct the student's error. Well, let's just go ahead and graph it and then see if our graph matches theirs, and we can see where the error is. The first graph is x is greater than or equal to minus 2. Notice the boundary line here would be x equals minus 2. That's simply going to be a vertical line at x equals 2. Notice it's going to be a solid line, and although normally we say above, in a vertical line above means where the greater number, so they're going to be to the right. So in essence, if I were drawing this, I'd recognize that my graph's going this way. Just slightly for now, because we have 3 equations, so we don't want to mess it up too much. And so then, and if we look over here, here's our line. He's obviously graphed that side, so it looks like he did that one right. So let's look at the next one. Y is greater than 2. Well, the boundary line for that is going to be y equals 2. So that's going to be, in this case, greater than, though, means dotted or dashed, and we're going to go above. So there's my line, and in this case, I'm going to go above. Okay? Now, if our answer stopped there, we would notice that right now we have this area here as possible. But when we look up here, here's the dotted line, but notice the student graphed below. So the error, the first error we find here is the student graphed this one incorrectly because he graphed it below the line instead of above the line. So there's at least one error. Let's see what we got for the rest. Our next graph is 1/2 x plus y is greater than or equal to 0. Okay. So I solve that. I subtract 1/2 x from both sides, and I get this. And now I notice to graph, my boundary line would be y equals that. My slope would be minus 1/2. And notice there is no intercept because it is understood to be 0. So that means my y-intercept is at the point 0. Greater than or equal means solid and above. So from this point, if I go down 1 and over 2, you can see my graph's going to look like that. I'm going to graph a solid line, and I'm going to grade above. All right? So everything goes above the line. Well, one thing you'll notice is this original graph we had just with the blue and the green, all of that is above that. So in essence, that becomes our actual solution. Now you will notice that one thing that went wrong with the student, they came down here at 0, but instead of going down 1 and over 2, they went up 1 and over 2. So they made the mistake of graphing plus a slope of plus 1/2 instead of minus 1/2. So there were 2 errors on this. The actual solution should look like the yellow there. Problem 4 is about gift certificates. You received a $100 gift certificate to a clothing store. The t-shirts are $15. The dress shirts are $22. You want to spend no more than the amount of the gift certificate, and you want to leave at most $10 of the gift certificate unspent, and you need to buy at least 1 dress shirt. So let's get started putting this together. First of all, let's define our variables. I'm going to let X be the number of t-shirts and Y be the number of dress shirts, so I can go to my graph and mark t-shirts and dress shirts. I went ahead and put the numbers in, since I'm assuming that even if I bought all t-shirts, this would be enough. 8 t-shirts would be over $100. We're ready for that. So let's go to our first one. It says that we have $100 and we want to spend no more than. So if I have $100 and I want to spend no more than, I can spend $100, but I don't want to spend $101. So I can spend $99. So I'm looking at an equation that's an inequality is less than or equal. So my first inequality is I spend $15 for each t-shirt, $22 for each dress shirt, and it has to be less than or equal to 100. So let's graph this. First, let's find our boundary line, which is 15x plus 22y equals 100. So let's find our y-intercept first. Let x be 0, and we're just left with 22y equals 100. So y is about 4.5. So we can mark that on the graph here, right here, 4.5. And that's my top point there. And let's go to our x-intercept. Let y be 0, and we have 15x equals 100, so x is about 6.7. So we can put that down in here, about 6.7 someplace. All right? So there's our lines, and we can draw our line. We have less than or equal, so that's going to be a solid line, and we're going to shade below the line. Okay? Let me erase these little marks just so we don't get them confused here. But in essence, I'm going to shade below the line here. I can do this as my little X's if I want to. Somewhere below that line. Okay? Now our next one says that we want to leave at most $10 unspent. This is a little tricky because what I want at most is, again, I want $10, but I want it to be at most so it can be equal to that, but it has to be less than. But now when I go to write my equation, here's the problem. If I want $10, what I'm really going to have is I want this to be, instead of less than 10, I want it to be greater than or equal to 90. In other words, if I take away $10, I want my thing to be bigger than 90. If I spend $89, then I'll have $11 left. So it's a little tricky because I end up having a greater than, even though it's an at most. It has to be, what's left has to be 10, but I'm going to write this as 90, 100 minus 10. So now we essentially have the same equation, but with 90. Now it's 15x plus 22y is greater than or equal to 90. Okay, so my boundary line is very similar, equal 90. And so now we end up having, this time my y-intercept is 4.1, so it's going to be about right there. And my x-intercept is going to be about 6, about there. Okay, and again, it's solid, but this time it's above. So I'm going above. So if you think about it for a second, and I'll draw this right here, my red one's going down, and my blue one's going up. So right now, the area that seems to be what we're doing is going to be in between here, is what we're looking at. Okay, does that make sense? But we have one more parameter. Okay, we also have to have at least 1 dress shirt. So my next thing I notice here is y, the dress shirts, has to be greater than or equal to 1. So I find the 1 equal 1 and graph above that. So the green's going to be above. So notice where we had the original yellow, we're talking about inside this line here. Okay, So I'm looking at this and saying, okay, I'm going to fill in here, but I'm going to go down and I'm going to stop at the green line. All right? So we end up with a graph that looks something like that. Now, let me erase this just so we can see better where our points is, because the next question is to pick 2 points. So I'm going to erase what we've drawn in here and just kind of leave our graph there. And we're looking for points that are possibilities. Now remember, you can't buy half a t-shirt. So we're going to be looking at places in that graph where the lines cross. We need a point like that. So I found 2 of them, I think. So one of them is right there, and that's the point 5, 1. And the other one I believe is right there, 2 and 3. And if you want to check those, you can put those into your formula again and see that you have got the right amounts. But those would be my 2 possible answers. For example, take 5, 1. 15 times 5 plus 22 times 1. So 15 times 5, 5 times 5 is 25, carry the 1. So I have 65 plus 22. And so you see I end up with, no, I carry the 2 here. Sorry for that error. So this is going to be 75 plus 22. And so that adds up to $97. And notice that is less than 100 and it's greater than 90. So I've tested that, and that's the solution. And you can do the same with 2 and 3. If you think you have another point, like if you pick a point here and you think, for example, you think that's close enough, looks to me like it's outside, but if maybe you thought it is, you could test it and see if it meets all of your parameters. Problem 5 is a geometry problem. It asks us to graph the system of linear inequalities and then answer a couple questions. So let's get right into it. First, our first equation is x is greater than 3, greater than or equal to 3. So the boundary line would be x equals 3. And I notice this is also going to be greater than or equal means a solid line graph above, or in this case with a vertical line graph to the right. So there's my line, x is greater than 3. And you can notice that all my lines, all my answers are going to be on this side of the graph. Okay. My second one is going to be y is greater than minus 2. That's going to be a horizontal line at y equals minus 2. And it also is solid and also above. So notice minus 2 goes off our graph, but I can still put it there. And now I'm going to graph above. So it's going to be above the line here. Okay. So at this point, you can see we have to the right of blue and above the green. That's our answers. Okay. And then our last equation, x plus y is less than or equal to 5. Let's change that to slope-intercept by subtracting x from both sides. Don't lose the negative sign when you do that. And now I see my boundary line would have a slope of minus 1 and an intercept of 5. So I can come up here. It's going to be a line that's solid, and we graph below. So I go up here to 5. And now I'm going to go down 1 and over 1. So my line's coming through here. We did say it's solid, and it's going to be, we're going to graph below the line. Well, if we look, what is to the left of the blue and above the green, and yet below the red, and we end up finding our solution to be right there. See, it's below the red, above the green, and to the right of the blue. So those are our answers. So here's the questions. First, describe the shape. First of all, I notice it's a triangle, but it is a special triangle because actually here it is a right triangle. What are the vertices? Those are the points of the triangle. First of all, there's 2, 3, 2. Then there's 7 minus 2. And then there's the point 3 minus 2. What's the area? Well, the area of a triangle is 1/2 the base times the height. Notice if I just look over here, I can see this is 1, 2, 3, 4. And this up here is 1, 2, 3, 4 as well. So it's actually an isosceles right triangle. So I end up with 1/2, 4 times 4. 4 times 4 is 16 divided by 2 is 8. So my answer is 8 square units. Problem 6 has already graphed these two inequalities and just wants us to figure out which area should be shaded, what region has the solution. So let's get started here. First of all, if I look at the first equation, I notice immediately that the slope is minus 3/2, and the y-intercept is -2. So I can see right here, here's my -2, and you can see it's going down 3 and over 2. So the red line is my answer. Less than or equal means solid below. So I'm going to put an X here and an X here. So it has to be below the red line. That means the other one is my blue line. And so if I put this into this form, I can solve y is greater than 3x is 2. And you can see here, yep, there's my 2. There's a positive slope of 3. This, though, is greater than or equal, so it's solid above. So I'm going to put little X marks above. And now the question is, which region has 2 X's? Notice this one has no X's. This one has 1. This one has 1. But here, 3 has 2. That's what we're looking for. In other words, if I were graphing this, this would be the area that I would graph. So the answer here to our question is C.